do this thing. Okay, so this is a repeat, sort of a redo maybe, of the second half of the wireless, multicast on wireless. Okay, so you already heard, why you want to listen, blah, blah, blah. This is where we let off. So how does multicast on wireless work? So this is from the perspective of the sender. I send to the AP. Now think about Macs, right? So we're not typically doing peer-to-peer unless there's some specific exceptions for that, but typically we don't. We send to the AP is going to read forward, right? So I'm going to have the first destination MAC is going to be the AP, and then the other destination MAC is the multicast MAC. Okay, and I could have more if I'm coming in from a mesh network. So sender just sends it to the AP. Okay, so there's a little bit more than, slight bit more than if this is wired. Wired, destination MAC is the multicast MAC. Drop it on the wire, done. Right. This one, it's like, well, okay, everything's got to go to the AP. Okay, there we go. Snooping on the controller level says, yeah, I got clients on that WLAN, on these APs, and on this WLAN and those APs, and these are the groups they want, so that the controller's keeping track of that. And the traffic still gets forwarded to the AP, it just doesn't send out. It's not supposed to be sent out the AP if it doesn't have clients. And why do you care? And the real short on this one is, this is radio. So whenever anything is being transmitted, no one else can, and particularly on 2.4, on that channel or the adjacent channels, can transmit. You're just creating interference. Okay, so that's why we care about not sending it. Okay, and if I have one VLAN but it has multiple WLANs attached to it, and I've seen designs like that, and it can make sense, right? If I need to have like a special PSK, but I have them dropping in the same, like say medical device LAN, I could do that. Put a couple devices with the PSK, and it's different. Needs to be a different WLAN. Okay, and then it drops the stuff out on the wired network. The controller does, and that way, because it really needs to get to the VLAN interfaces, which will not be on the controller itself, so that it's not, because the controller's not a router. So it's just going to drop them onto the wired, and then the wired network can do with it as it needs to, as it makes sense. And then it uses CapWAP to send them to that multicast group address. If you're using the multicast group mode multicast, if you're using unicast, it's still going to be in CapWAP. It's going to be in the regular data streams. And this last note about the layer 3 roaming, I pick up a new IP, I need to move. I need to the new SVI I have to get a report out to the new SVI that says, I want this traffic, I want this group. Okay. And we talked about this. Let's move on to the new material, which is this. Okay, so low reliability. Typical for, you look at ABG, every packet that got sent got acknowledged to say, I not only have it, but it's also came in uncorrupted. This makes no sense for multicast, because I'm supposed to have a group. 0 or more computers, yes, but if it's 2 or more, do I have to keep track of all the listeners and then say, oh yeah, okay, so machine number 1, 2, and 4 acknowledged, but oh, I got to rebroadcast because of 3. That all has to happen out of band. That the problem is that with wireless, think about 2.4 in particular, 2.4 gigahertz range in particular, there's a lot of other things that are allowed to use that range. And 5 gigahertz has things that also are in its range as well. So there are things like cordless phones. There are, for 2.4, Bluetooth. And, most wireless engineers will tell you that like a single Bluetooth instance is not something I'm all that worried about. However, if I'm wall to wall with wireless headsets and wireless keyboards and wireless mice, like in a dense area, then that starts to add up and become a problem. So you have all these things, and it could be things like microwave ovens that cause the interference to the signal. And if you're not clear on it, the idea is that my wave impacts another wave, that they'll either add, make the wave more powerful, or will diminish it. And if that's random, the problem is if I made if they were absolutely perfectly in sync, that's great. They would just make the signals stronger. But if they're not in sync, perfectly in sync with each other, is that a low because of interference, or is it low because you meant it to be a low, right? Or is it high because you meant it to be a high, or because it got boosted by interference? Don't know. Have to toss the packet. Can't do it. That causes a reliability issue. Data rates. Okay. You're using one of the mandatory data rates. The mandatory data rates are all in the ABG range. They're not in AC or N range. So multicast will never use those rates as multicast. And it's supposed to be, if I remember right, it's the highest mandatory, but you don't set the highest mandatory to the highest speed possible. Even that, right? Not even 54 megs or megabits. That I don't, because then I have a different problem. And I think that's on the next slide. They fixed this kind of with 802.11v. And the idea is that the client can say, I want this as unicast, and if they're connected via an N or AC rate, that what I'm doing is, yes, I'm sending more packets, but because I can send them, and the thing about the higher rates, there's a lot of things to know about that. One of the things about higher rates is that one of the things we use more subtlety in things like phase shifts and that to be able to pack more data. And the idea is that the bits are symbols, and for the same number of bits, because of all these subtleties that I can do with phase shift, with amplitude, because when the signal is loud enough and there is so little, there's not enough noise to cause significant interference, that I can have less redundancy, and I can have the same amount of data representing the same amount of radio frequency represent more denser data. So that's why you talk about the 64 QAM, 256 QAM. That the idea with 256, the symbols can pack a lot more data in there, but I also have less redundancy. So how much airtime I take to send the same amount of data is much less. So if I use, particularly if I had some of the very high rates on AC, I can take this multicast data and shoot it to a whole bunch of clients a lot faster than I could at that mandatory data rate. So this one is a huge bonus, but you notice it's not multicast anymore. For like the old style Ethernet with that shared medium, it was a fixed rate. So if I buzz 10 packets across that 10 megabit link, well, I'm taking up 10 times the space, 10 times the amount of time on the line. It takes 10 times longer for someone else to get a chance to send their data because it's a shared medium. This one, because of the different rates, I mean, it would make sense somehow if every broadcast had to go at a 10 megabit rate, and given now with multi-gigabit Ethernet that I can go up to 10 gigabits depending on my connection, that having multicast then as it would make sense to just drop it, forget about it, don't do it. And that's what's happening on this wireless, okay? High interference. And this one, they're not taking the same interference I was talking about on the reliability problem. We're talking about really talk time. And my example I like to use is if you ever played with walkie-talkies, modern ones have all these different, and actually it doesn't even have to be that modern, but they have all these circuits that are blocking a lot of stuff you don't know you're being interfered with. So for example, you have like buy these Motorola two-ways and you using a repeater, you key down and it takes a minute for it to come back at you and give you the tone to tell you you've got the repeater. That's because somebody else is using it. You just didn't know that because it's got digital encoding on it, so your radios get that signal and go, I'm not going to repeat this because it's not my stuff. That in this case, it's that same problem. And so my experience was, in the old days, you played with these walkie-talkies. They had very simple circuitry. A lot of them had a single channel. And there was this guy who'd get drunk in the middle of late at night. We were teenagers, right? But he was an older guy. He'd get drunk and he'd get on the one channel that's most common for walkie-talkies, and he'd be blathering away about how it's the marine fishing channel. We all need to get the heck off. That's interference. He's interfering with our ability to communicate because he thinks it's some sort of fisherman. So we call them the fishermen and we'd yell at him and it's stupid and childish. But hey, we were kids. But that's the idea. The amount of throughput on that channel is severely reduced because of this other transmission. In this case, with multicast, going at that slow rate takes a long time in the air. That's creating interference. The other issue you had was power consumption. So since I'm streaming this stuff, well, a lot of devices are shutting off their radios for very, very short intervals to save battery. Go off, come back on again, go off, come back on again. Problem is I'm missing my multicast packets. So again, with 802.11v, they picked up some of this and they said, well, with this direct multicast service, one of the things I can do by now converting to unicast, I say, AP, you buffer this stuff. And when I wake up, you're going to give it to me. Now, there's not extreme buffers. This isn't like, oh, I took a nap for like 10 minutes and you held everything for me, right? No. These are in milliseconds. These are small chunks of time. But if I had to leave the radio on all the time, I would wear my battery down. And we're talking about mobile devices, so phones, tablets, even laptops. A laptop, you can even get sometimes the jumbo batteries, and I remember when you could buy like these slip-ins and take out your alternate media, your CD player or whatever it was, and stick in an extra battery. You do all that to add battery life, but still it has a maximum life. It has only so many milliamps, so many amps it can draw over a course of time before the battery is exhausted. And so by being able to go to sleep longer, that is a huge benefit for battery endurance. Okay. And then talking more about these fixed data rates, this is another interesting problem. So I'm a broadcast. Now, a typical broadcast uses the lowest mandatory rate. So really everyone inside the cell should be able to pick up that signal. This one wants to use it like the highest mandatory, but the idea still is maybe we need a lower rate, maybe we can support a higher rate. We're not going to negotiate. It's just a broadcast. It has a speed. It's just going to do it, period. And this rate depends on the received signal strength indicator and the signal to noise ratio. We can set one mandatory rate as the lowest allowed, and then we use that rate and all of clients can receive. Because the other problem, which we address now in this next, is that if we don't use this lowest rate, it is possible, lowest allowed rate, it's possible to have clients who are inside my cell, but because of the RSSI and the signal to noise ratio, that it's had to downrate. So it's had to go to a rate that's below what multicast is using. It can't understand. There's too much interference for it to pick out that signal. And for the signal to noise and RSSI, the idea here is that, look, if you've ever been in these, like they have these special test chamber for these super silence rooms for testing hearing. They're special, or they seal in kind of thing, absolutely dead quiet. There is no noise at all inside that little cubicle. And in that room, if there were two of us in there, I'm sure we heard each other's breathing fairly easily, and certainly we could be, if we're close enough to each other, absolute whisper and hear each other. However, if I was on like a big industrial plant with like a lot of machinery, think of like auto manufacturing with, you know, those big welding robots and, you know, cranes and all that kind of stuff that it's using, the conveyors and all the rest of it. In that noise, I would, no way, can't communicate. I need to have a lot stronger signal to have enough difference over the noise to make myself clear. Okay. And so in this case, you've downrated because just the signal's not strong enough. There's too much noise. I need you to send me and these rates, it's not like they're sending the data particularly faster. It's about how much redundancy I have in the signal, and then how subtle the encoding is. I can break it down to like a binary kind of, rather than using these, the QAM, quadrature amplitude modulation, where I use 4 different phase shifts, and then I also vary the amplitude of the signal as a way of doing a much more subtle encoding, that it's just lost in that. You know, another example is that a long time ago there was a strike at the Philadelphia airport. The striking, it was one of the rental car companies. The striking agents their union hired this big sound truck because there was no sound ordinances right at the airport. So they were blasting "We Will Rock You" on continuous repeat at, you know, near lethal volume. And so out on the lot, apparently you just had to scream at each other. It's the only way you can communicate. You had to scream, or you have to write things on paper, like you can write a note, you know, that you couldn't, because the noise ratio there was so large. Now that means there's no subtlety in communication. I can't do this sort of, I'm going to kind of be more quiet and subtle, and, you know, now I'm going to be more emphatic, and now because I'm angry. You're like, no, everything's just a scream. Okay, so you think about that. That's the thing about data rates. And so there can be this ring of clients. Usually it's because of distance, because the signal is, as the signal spreads out farther and farther, and think about like throwing a rock in a pond, the waves rippling out concentrically, but they start to diminish because that circle gets bigger and bigger and bigger as it expands outward. So by the time you get outside a certain radius, that you don't see those ripples anymore, if the pond's big enough, right? Okay. And then this DMS should help resolve that issue. Okay. Now, multicast DNS. This was one of the solutions for the problem of home networks. So for home networks, Microsoft's first solution, when you look at NetBUI and that, and their first Windows for Workgroups, that we'll broadcast. We're all just going to broadcast to each other. We're all going to learn about, we're going to send these regular broadcasts, and we have a browse master. It's going to keep track of it. And so, you know, when we say, hey, where is this? The browse master is going to answer. With IPX and Novell in the early days, it was SAPs, service advertisement packets. So I'm going to send these advertisements, and we route the advertisements, which can get interesting. If you had a large enough Novell network, that at a certain point you'd have to start filtering SAPs, because there's a limitation onto how many SAPs things will keep track of. So you'd have like printers dropping in and out of your printer list. So MDNS is one of these solutions. It's designed for home networking. However, it has some application. So I'll give you an example. One of the things you might want to do is have people doing demos, and they'll be on their tablets and they'll be showing things they want to put on a big screen. And one of the ways you do that is using like this AirPlay functionality. So I can have something like an Apple TV. So Apple TV attached to like a 60-inch, 70-inch, some gigantic screen, right? So, but if for reasons, if the Apple TV is on the wired and you're wireless, well, if those aren't the same VLAN, then they won't route because this stuff is link local. But one of the things that Cisco has done with the wireless LAN controllers is it has a proxy, so it can go, oh yeah, I know about an AirPrint printer, I know about AirTunes, I know about AirPlay. This is where they are, and there are other. You see Google Cast, HP PhotoSmart printers. There's a number of these things that are have discovery capabilities, and it uses this MDNS. So that's another application for DNS, and we have MDNS snooping turned on. I believe that's on by default, and you may not want it. It's like, whatever, you Apple people, don't care, not gonna happen, not gonna. And there's some more advanced topics in terms of filtering and the rest of this. There's a lot you can actually do with this when you really take all you can out of your Cisco Unified Wireless Network. Okay, so there's multicast. So over wireless. So we had talked about, we started with just the basic layer 2, what IP range, what the MAC addresses look like, how the MAC addresses are formatted. We talked about IGMP, the 3 versions, 1, 2, 3. We've talked about PIM, and we've talked about sparse mode, sparse dense mode. We talked a little bit about bidirectional over time. We've talked about source specific multicast, right? We've talked about rendezvous points, RPs. We've talked about MSDP and how to sync the sources between rendezvous points. We've done that. We've talked about boundaries. We've talked about security, and now we've added wireless to this. Last 2 topics, and we'll start one of them next week, is one of them is IPv6. So we focus exclusively on IPv4. The fundamentals are still there, right? So we just changed this name to MLD, Multicast Listener Discovery, because you think about Internet Group Management Protocol. Okay, you'd think that has something to do with the sources. It doesn't. So only if the source is also a receiver does it care about IGMP. But MLD is focused on receivers. So we'll do that. And the other one is static routing. And the static routing case looks like it's always possible that your carrier, if this is a layer 3 link, says, I'm not doing that multicast garbage. Nah, not there. Or I'll do that for you. Yeah, sure, fine. That's going to cost you this, because there's a lot of times to make multicast work in a WAN, if it's like a Metro Ethernet and it's truly just Metro Ethernet, it's fairly straightforward. But when you start having other technologies glommed in there, which is the whole point for a lot of this stuff, that yeah, some of the other technologies are not as easy to deal with multicast. So you just may say, hey, well, yeah, I'll do it, sure. And I'm going to charge you, 4 times as much. Okay. So that creates an interesting problem for you when you're talking about how to fix that. So I think the IPv6 will be the next segment. I'll work on that this weekend for next week. And of course, we're not going to do a 5-day schedule at this point, unless I start redoing some of my old talks, which I may do that as well. But there you go. So we've kind of gone through all this stuff. And so then here's your questions, your homework assignments. And why do I do this? Just to kind of give you some stuff to focus on. Therefore, you could, did I understand like this? Some of the questions I think are straightforward. Do MOAP sit across multicast boundaries in the WLC? And that can include things like, hey, there's no PIM between them, because what I just talked about moments ago with your carrier saying, no, we're not doing this, right? So that's important to know. And if you're not going to go and fix that problem, then your next choice is, well, maybe I don't use multicast mode multicast. Okay. Are my WLCs enabled for multicast, and what mode are they using? So I'm using mode multicast or unicast, and this feeds right into that first question, right? Is the group using this range, and do I need to change it? And are multiple controllers other than an HA pair using the same group IP? Right? We've generally said, yeah, you don't want to do that because you're going to get the same traffic. It's going to get dropped further on, but my APs can be getting that same traffic from multiple WLCs that they don't need. They're going to get all of it. They can get all of it because of multicast, right? So you don't want to do that. And then the AP just drops it because it says, hey, you're not my WLC. I don't have to listen to you. And do I need to build filters to protect from forwarding fragments? And this was the, so getting back to the changing the IP address, if it's a registered IP address, and don't. Because if you ever want to run that application now you have an interferer. You don't want to do that. If it doesn't meet with your scheme, say this boundary statement, if I change, it does need to cross the boundary. I have a range that can cross the boundaries, but I set this for a different range, then change it. If I have other applications using that IP, change it. If it's in the 239.0.0.0/24 or 231.128.0.0/24, change it. But also understand what that impacts, right? Obviously, right now in the middle of coronavirus, if I was supporting something like a hospital, a virology lab, and they're running 24/7, they're flat out. They've got either working on critical stuff for corona, either patients or lab testing, vaccine work, whatever, medication, whatever. Yeah, I would probably not change it right now if it's not breaking anything, because I don't want to interrupt them. I don't want to cause any potential interruption for them. So I wouldn't. Otherwise, I'd do it, right? And do your proper change control, of course. Okay. And the WLANs need multicast enabled. And remember, you're going to go enable multicast on the VLAN interface. The WLC doesn't route multicast. So if it comes in on, your voice VLAN and there's something on the, say you have like a Jabber client on the user VLAN that also needs to get that multicast, the controller won't do it. The controller needs to feed that to the layer 3 router, SVI, whatever it is, then that needs to forward it across, and then it'll come back into the controller for the controller to now feed it down that WLAN. Okay. So you need to enable PIM on both those interfaces. If it's just inside the same WLAN, it's less of a deal. So you don't really need to do the routed interface. So that's your to-do list. Hopefully those helped you focus this. I'll upload the slides on the slide share. Follow me, follow my YouTube channel. And like I said, tell a friend, they're interested. Somebody's on tech topics. The more I get, eventually I can have some channel that's not quite so psychotic, but you can go to my LinkedIn, follow me there, and you'll get you can get these slides, and you could capture that, right? So, send me direct messages on LinkedIn, put comments on YouTube or on LinkedIn. Just saying thanks is awesome. I love that. You have questions, clarifications, you want to reach out to me because you want to talk a bit more about multicast, we can do that. I'm always happy to have, short kind of like, this is what you should look at kind of questions. Obviously, if it's something, I have done a little longer for friends sometimes, but if it's a long engagement, then we can talk about it. And just like within these topics, I'll tell you if I think that's a good fit or not. If you came at me and it was a bunch of non-Cisco gear, I would tell you up front that I'm going to have trouble estimating the job, and that I would say that we're going to do time and materials. If it's, and in terms of rate, then the question gets to be, if I think it's going to help me, then, I might be a little nicer on the rate. But if it's some consumer gear that I'm probably never going to run into again, yeah, I'm going to need to charge you a decent rate for doing it. And it may make it economically, just not a worthwhile endeavor. But ask questions. Anyway, there you go. I'll have this thing up. Should have it up late today. Take care. Wash your hands. Stay home if you can.